Well, good morning, everybody. To finish up this week of forecasting, I want to go back and revisit some of the maps we've been paying a lot of attention to over the last several weeks. The first one here looks at the last 60 days in terms of percent of normal precipitation. So the narrative has been most of the last 60 days have seen large ridges across parts of Canada, anomalous flow out of the east. We've had a lot of upslope, thunderstorms that have blown up, and then a stalled out stationary boundary in through this area on through which we've had just a tremendous amount of thunderstorm activity. Here throughout much of the Midwest, the Mississippi Basin, part of the Missouri Basin, the Ohio River Basin, the Great Lakes Basin, this has been the area that we've kind of targeted for having just a lack of upper level flow. We've had just pieces of the jet stream not extending into this area, which has been a major part as to why weather systems have not rolled through this particular region. In the last 30 days, that drought has gotten quite a bit worse, kind of centered right here inside of the area that I'm circling. And despite a couple of chances of moisture coming through, overall, it did not undo the longer term drought stress that was in this area. Meanwhile, we do have places along the high plains, the western plains stretching from Montana down to Texas into this area that have measured, there's a few places that are over 1,500% of normal precipitation during this time period. My color bar only goes up to 325%. So there's some extremely wet conditions here. And in addition to that, very heavy rainfall like the stuff we've seen over the last week. I mean, you can just take a look here at the last week's worth of rainfall. We've had a lot of hail in this as well. I'm going to come back to the hail in just a few moments, but I really like looking at these maps. But I understand my color bar, it's a bit busy, but we try to show all the distinction here. So I'm going to once again show you the last 7 days through this morning of total precipitation, but we're going to get rid of everything below ½ of an inch. So we're just trying to identify where those holes are. And the reason why we lop off a ½ inch is because a ½ inch rainfall can evaporate in a day and a half or 2 days if the heat comes back on. But the heavier rains, the more steady rains tend to do a better job at soaking in before the evaporation occurs. Now, again, a lot of what we've seen in through this area, all of this, we've had quite a bit of hail in this. And the extremely heavy rains we have over here in parts of Georgia, the Carolinas, and Virginia, this has been because of this cutoff low that sat in this area and slowly meandered its way up the coast. It's interesting to say this, but had a system like that formed this winter, we would be talking about huge snows in the Appalachian Mountains and throughout the Carolinas all the way up into New England as this continues to go. But we didn't get storm systems like this winter. We did not have troughs along the East Coast this past winter. In fact, we had ridges, and it was very, very mild. That was actually what helped the Midwestern United States break a long-standing drought. But when that went away, all that came back, all right? So just to see some of these numbers over here in the Carolinas, so a lot of area picking up better than 3 inches, and some places, as you can see, topping 6 inches just in the last 7 days. I kept mentioning hail. I want to show you the last 3 days of hail reports. So we've seen a lot of national news coverage of some of the big hailstorms that have hit parts of Colorado, but that is not to ignore what else has been going on here all throughout this corridor, kind of wrapping itself around the drought-stricken region. Now, thinking about that, I did want to revisit something I showed you earlier in the week, but I want to do a little bit more complete, complete analysis of it. So it's interesting to show, here's the big outbreak in tornadoes that happened on March 31st, and then we kind of flattened out, and then we had another large outbreak here in early May, all right? Since then, this is when the drought really began to build, and so we just didn't keep pace with normal. But this bump right here, which has taken us back to climatological normal, has primarily been happening in the plains, down to the south and into the southeast. Normally, if we're going to see a bump up in this area, it's happening in the Midwest, the upper Midwest, northern plains. So this just shows you how odd this pattern is. On the hail reports, remember this trend line here, okay, which is a 15-year average. Many of the reports in here are from those are from the time period when we used to use the lower threshold for hail. So to see this near average means this has been an extremely active year for hail. And the category that I am most worried about going forward is this. It's our wind reports. When we get into the month of July and August, that is the time of year where we tend to have lots and lots of squall lines across the United States. And I'm especially concerned about it this year because if this drought, which has been developing for the last 2 months here, if this drought is going to break, it will not break gently. There is no indication right now, especially given the big ridge that's sitting right over this area, that we would just have gentle, low-pressure systems delivering a day and a half worth of rain. What we will likely get are squall lines of thunderstorms that come ripping through, and unfortunately, if you have drought-stressed crops, they tend to not have the same stand quality. And so I'm worried about that now, that we are starting to see some signals of better chances. It's not perfect, but better chances of storms in through this area. So I want to show you another aspect of the drought monitor. Now this comes from drought.gov. And what you're looking at here is the current drought reduction. So this is what we also call drought amelioration. So what we've done here, as I've said, if we have to break the drought in a month, what's needed? And I'll link this in the notes below so you can go play around with it. But it's absolutely crazy. And I think I have not, I don't think I have not given enough attention to the drought that's in this area. I've been focused on, I probably have some backyarditis about my climate reporting district here, where we would need 8 inches in July to break this drought. But if you come over here to parts of Nebraska, northern Kansas, I'll just pick this district here, which includes, Omaha to Lincoln and nearby areas. They need nearly 18 inches in a month if they want to just completely end the drought. Of course, that would be kind of like ark building flood type situation here, but this just shows you what it would take in given regions to break the drought. So I'll link that below so you can check it out. Now, like I said, it's pretty rare in summer for drought to break gently. Wintertime, sure, but not in the summertime. And one of the things I'm concerned about comes from some research from one of my former students and his advisor now for his PhD, or the PhD he finished. His name was Corey Gaustini, and his advisor was Lance Bossart. And they studied, they put together a May through August climatology of derecho events. And you can see that this is the area through which we have the highest return frequency of derechos. It is here, and it is also down in this area. And the trajectory of these is almost always in not almost always, but favors northwest. And the reason for that is if we build ridges into this area, you tend to get flow over the top that comes in like this. So it initiates storms, but there's weak upper level wind shear, and therefore the storm system itself defines its own wind shear parameters. It's typically unidirectional, which means the storms just build into the unstable air like this. Now, what has to be in place in order to have a very active squall line season is you have to have something that's already opened up the Gulf to pump moisture into here. And we know we're missing that component. But what I'm telling you is that if the drought is going to start to break in these states that have been extremely dry, this whole area, it will likely break with, I hate to say it, but severe weather. So let's go take a look at the most recent radar data. This goes back here over the last 12 hours or so. More storms. This is overnight last night into early this morning, still continuing to come up the East Coast and just hit the same areas harder and harder again. Some of this has backed itself up into Ohio, which is much needed. This is really helping to prevent any more deterioration of the drought conditions here. But then you come over to the plains and we just watch these complexes of storms erupt day after day here, coming into Colorado, Wyoming, into western Nebraska, and now into the Dakotas. And we're waiting on, it's very subtle, but it's way back over here. There is an upper level wave coming through. There, we just got a quick reset. Upper level wave coming through right here that's going to eject very soon this weekend into the northern plains, and that's going to be a critical one to watch. That wave is right here. Here's the large Texas into Mexico ridge. Here's the downstream trough. Do you see how it's now open? There's no longer a closed low, which means that's going to start to move. We have Brett and Cindy. We'll talk more about that in a few seconds. But it's actually what's coming around here and here that eventually is going to come through again and give us another chance of storms in the Midwest come next Thursday, Friday. But before we get there today, the risk is going to again be in the plains. We've now seen the Storm Prediction Center increase this region to an enhanced risk. So we're going to watch for hail, straight line winds, and tornado damage possible here. Going into tomorrow, this will be Saturday, we're going to watch very carefully the southern edge of this low that's going to curl up here in the Red River Valley. And we will have the ingredients for 2 different rounds of thunderstorms coming through parts of Iowa. And the question is, will they extend into Illinois, and what will be the time they get into Illinois, given that this is one of the driest spots in the Midwest? From there, we notice again that the threat on Sunday shows up in the Ohio River Valley, right into this area. And what I don't like to see this time of year is kind of this banana shape. So what's going on here is that this is kind of showing us that the probability of having a line of storms, like we just talked about, bending but heading in this direction, begins to increase. So let's go have a look at it on the high-res model. This is going to start off at 7 o'clock this morning. So here's the pieces we just watched on radar. So overnight, the storms did last in places. But the main wave is going to move today through Idaho into Wyoming. So this is all out ahead of it. This is a weak little shortwave out ahead of the big wave here. A lot of isolated convection across a broad section of the east, possibly in parts of Missouri, Kansas. We could watch for some pop-up storms. But this is 2 p.m. this afternoon on Friday. It's getting into the evening hours. I'm going to watch carefully. You see coming out right here in Wyoming, back up into Montana, but into the Dakotas and Nebraska. We'll keep an eye out. Isolated convection south of that into Texas, where we've seen it multiple times this week, and rains moving through northern Minnesota. Now, as we go into early Friday morning, now watch, you're going to see the model put the orientation of these storms in these kind of arcing lines. This is early Saturday morning. Should this survive overnight and roll through parts of Nebraska, hitting parts of South Dakota, maybe around Sioux Falls, and then getting into Iowa, this would be round one. But you see they fizzle out from 2 a.m. to 7 a.m. because that's a very stable time of day. But that boundary is going to keep moving. It's somewhere in here, and it may initiate storms later in the day on Saturday here. But what I'm going to watch is what happens behind it. This is round number 2 on Saturday afternoon. North of it, a lot of this is going to be that, what I would call perfect rain. Several hours of gentle rain, not the major thunderstorms here when we get into the night or afternoon on Saturday. But to the south, this is where the severe weather is going to be. Now notice, the model by 7 o'clock is attempting to get this squall line to cross the river. Now, I know we're looking at a single model run, but we're going to have to pay attention to this. And I apologize, I didn't cover too much about New England because I'm watching the storms come through these dry areas here. But this is going to then possibly move through and leave a lingering line of storms coming through Illinois. Now, what we always worry about is that if the storms, if these storms, as they come through here, are timed to come in the overnight hours, they tend to be quite skinny. They tend to be fading with time, and that's what the worry is. See how it kind of fades as it goes through Illinois a little bit? That would just be the concern that this underperforms because it's 2 a.m. Doesn't mean you can't get overnight thunderstorms, but it's just, that's the issue we have. We run out of the heat of the day to make these things possible, and I know there's not a lot of moisture here in the first place to use. But then later in the day, the next day on Sunday, we start to see where the storms get down here. We're going to watch again. Now that's round 1, again for a second round to blow up here on Sunday evening. So that's the setup of this system. I know we spent a lot of time on an operational run here, but let's break this out into some bigger views. 7 days from the WPC. What's changed? This area has been increased in terms of wet weather. We see the really wet conditions moving into New England. We've started to see this area showing up wetter as well. This contour line is a 1/2 inch. This one's 1.5 inches. So we still need to see more storms getting into these dry areas. There's better relief for Michigan, better for Ohio, but Indiana, Illinois, Missouri, Iowa, especially eastern Iowa, needs quite a bit more out of this. Could we get better storms into those dry pockets of Nebraska? Yes, but you can see the ridge down here. You can almost see the flow, and that's what we're going to watch. Next to the ECMWF. Here's the weekend storm systems. That's Sunday morning, Sunday evening. And then I told you there's a second wave. It's possible. So this is out to Tuesday. Could come through the same area right here. Watch this. This is next Thursday into Friday. And we do not have good information on this, but I'll just tell you the model did trend wetter in the day 8 to 9 time period for the state of Iowa. It did trend wetter for that. Let's flip over and see the GFS. That's out a week. Again, we're watching that next system come through here, and it's trying to put it through not Nebraska, but South Dakota, Minnesota, and Wisconsin, so much farther to the north. So the GFS leaves those same critical areas out much drier than the European does, all right? But we always look at probabilities, so let's go do that. What has changed in this? We can kind of see these very heavy rainfall areas. These have been identified very well throughout the week. What has changed is now we've got a corridor in through here that's got better than a 50% chance of grabbing 1 inch. And if I made any sort of modification to this, knowing where that ridge is located, I think this area in through here likely sees a lot of thunderstorms that are not well resolved by the models at this point. But that still kind of straddles an area in through here that has a lower probability of getting 1 inch. If it's a normal 10-day time period in July, these probabilities of getting 1 inch, defining normal here, okay, would be up there in the 80 to 90% range, because that's what we typically get in a normal summer thunderstorm regime throughout the Midwestern United States. All right, this is what the pattern looks like by day 10, and the models keep pushing the ridge back west. So that flow's coming around just like this. And why I consider this area to be kind of under the gun for more severe storms is I'm just watching the northwest flow on the northern edge of that heat on that 588 line. This is a relatively deeper trough, and we have to question, where will the temperatures be cold enough to support this as we go out to that time frame? Again, July the 3rd. Because I'll show you what I'm seeing here in a few moments. I think there's going to be quite a bit of hot air under, on the back side of this going forward. But that pattern, when you look at it, the week 2 precipitation forecast, we still see a drier swath in the European model, but the CPC is wetter across a broad area. The GFS is wetter across a broad area too. And it is important to note that there is heat coming into California. There's dryness in the southwest up into the Pacific Northwest. That's been shown. And some places out west really do need this heat. Okay, quickly, Brett and Cindy. Sounds like a couple of kids in the 80s running around out here. But Brett and Cindy are both tropical storms. The forecast tracks, let's just look at the ensembles here. Brett not doing much coming in here, but I'm going to watch the convection. We always watch storms in July and August here, because these are the ones that sometimes get their act together and find themselves north into the Gulf of Mexico. But this, again, on Cindy's tracks, tells us exactly where the Bermuda high is. It's not Bermuda. It's somewhere spinning out in this area, and that's been a long-standing story for us. Let's finish up with temperatures. This would be today's high temperatures. Playing into tomorrow, look at how cold the air is up here underneath that cloud cover and rain. A lot of heat stretches out ahead of this on Saturday. 92 degrees here where I live in Champaign. I will be at yet another swim meet, so we'll be sweating there. Maybe they'll let the parents get in the pool. Anyway, here's Sunday into Monday. That's when the system comes through, bringing in the better chances for storms in this area. But watch this on Tuesday into Wednesday of next week and Thursday. There it is. 90s up to 100. It's been a long time since we talked about that in California. Notice from Texas, which has stayed on the heat, we now have this larger area breaking out into 90s. And notice that right in through here, we may be talking about triple-digit heat. So this is out there when I'm talking about that trough developing here. So there's a lot of heat sneaking in on the back side of this. Now, I normally show you kind of the 5-day moving average, but can we do something different today? I show you a lot of probability maps. This is the map that shows the probability every 6 hours, looking at the chances of getting above 90. So as we just play this forward, there's a diurnal cycle to it. So this is at night, right? So when it dips down to like that, that's at night. Then you get up here to the next days, and we just watch these temperatures through Sunday into Monday, getting into Tuesday here. This is now going out to Wednesday. This will go out there until Thursday. That's a high probability above 90 here. Now watch what happens as we get into the month of July. This is now going into July the 1st, right there. This is July the 2nd, right here. And then as we go out there to the 4th, and then to the 5th, the ensembles are attempting to really expand this area with higher probabilities of getting temperatures well into the 90s. So if the rains do not materialize, like we've seen the forecast attempt to do them, we then bring on some heat stress here. The question is, do the storms continue to cascade in this area? Some of the week 2 models suggest that they do. I'm in a mode right now where I have to say, you've got to prove it to me in the near-term forecast. Otherwise, persistence will likely win the day. So that's your temperature forecast. There's a couple things I want to point out internationally for you. We've noticed that on some satellite data here that much of the North China Plain and Manchurian Plain has much lower NDVI values this year than last. And this is just starting to become a bit of a concern, because this is where we grow a lot of corn and soybeans. And so just thinking about those two crops specifically, we need to watch out for that very carefully, because over the next 10 days, there are pockets through there that are not expected to get much precipitation, like the North China Plain. But do notice how wet things are throughout Indonesia, Southeast Asia, and India. And then also very uncharacteristic of a developing El Nino. Take a look at how wet parts of Australia are. They've had deep low pressure systems spinning here and a big draw on moisture from the north. So this is some very, very wet early winter conditions for them. No major red flags for South America going forward. Continued storms throughout much of Europe, all the way over to Ukraine and the Russian wheat belt here. So it tends to be quite wet, but that gives you a quick international update. Hey, thanks for kind of staying with me the last 10 or 15 days as we've been going nonstop here. I'm going to take the weekend off, but I look forward to talking again next week. Thanks.